So for the folks that are still trickling in, this is a workshop, which means it's going to be hands-on. There's going to be exercises and stuff like that. By all means, you can follow through the labs or pair up with someone next to you. The labs are based on the latest nightly of Gradle, so it's based off Gradle 2.6, which is what's in master right now. So if you don't have that installed, you can go out and download it, or it's on some thumb drives that are making their way through the crowd. So just at some point, you'll want to get your hands on one of those. Or just cuddle up next to somebody that's got their stuff set up. Yes?
Any recommendations as to create an isolated installation to not affect my rest of my Gradle?
I mean, one thing you can do is you can just unpack it somewhere, and then when you call Gradle, just use the full absolute path to where that guy lives. Or just put some symlink somewhere in the... So what you can do is unpack that directory that has all the labs in there, put a symlink in there to the one that you unpacked, or something would be real simple. Yeah. Or reuse the wrapper. I guess I should be plugging our features. Solve that problem. Okay, so I think this is basically everybody that's going to be in here. All right. So this is the Gradle rules-based model configuration workshop. I don't know, this is the best name I could come up with. Right? New model configuration workshop, new configuration model, whatever terminology you want to use. So basically, if you attended Adam's talk earlier or Luke's talk earlier, this is sort of the last talk in that track, if you want to consider it one thing. Adam talking about like the very high level concepts, Luke talking about the new configuration stuff at a little more lower level, and this is where we're actually going to get hands-on and start actually using this stuff. Like, what are these rules you guys keep talking about? Right? All right, so my name is Mark Vieira. I'm an engineer at Gradle Inc. Rene Groshka is sitting back there. He can answer questions too, also an engineer, and there's a couple other Gradle folks in the background, or you can ask Stepan too. He's just sitting up here. No, he won't answer any questions. All right. Okay, so like I said, this is a workshop. It may not have been super obvious from the schedule, but basically there's two 90-minute sessions, this one, and then we take a 15-minute break and another 90-minute session. But it's all one piece, so you kind of have to stick around for both. You don't have to stick around for both, but it's all one continuous material. Right? So we have 5 labs, so everyone's getting a chance to get hands-on with the latest new version of Gradle and basically actual examples of how you would create rule source plugins and how you define rules and all that stuff, right? So we're actually no more talking about it at a high level. We're going to get hands-on, right? As a pairing is encouraged if for no other reason than just logistically it's a pain getting all this stuff separated out to everybody. So if somebody has their laptop and it's set up and it works, just pair with them. And again, this is going to be a very interactive type of thing, right? I'm not just going to stand up here and pontificate for 3 hours. Ask questions anytime. Feel free to interrupt me. We'll set aside some time at the end for questions, but if anything comes to mind, ask it at any point. Okay? All right. So some of the stuff we're going to talk about, motivation. I mean, really, Luke covered this for the most part in his talk. Why are we doing all this? But we'll talk about it a little bit more again. We're going to talk about configuration rules. What are configuration rules and why do we need configuration rules? We're going to talk about rule source plugins. What is a rule source plugin? How do I define a rule source plugin? How is it different from a regular plugin? How do I apply them to my project, et cetera? We're going to talk about what we call the managed model. Like, what is this thing? What is the difference between a regular model element and what's a managed model element? And how do I access it via the DSL and via rules? We're going to talk about the model DSL, which is basically how do I define rules, but in a build script via DSL rather as an actual like binary plugin. And then at the last part, we're going to talk a little bit about the software model or component model, which is basically an abstraction on top of the new rules stuff that things like the new C++ support is built on and Play support is built on, and eventually the new Java support will be built on this model. Right? We'll talk about that a little bit too. Okay, so why do we need rules? Again, some of this might be me reiterating what Luke probably said better in his talk. But we're going to focus on this in this workshop about folks that are extending Gradle, right? Not so much people that are just applying plugins and configuring them, but we're talking about build authors, build masters that are writing plugins that create extensions, applying those extensions to a project, then creating tasks that read stuff from those extensions, right, et cetera, et cetera, et cetera. Right? And like Luke described, that right now, that's just a humongous pain, right? There's all these hacky workarounds around, I apply a plugin, the plugin creates a new extension, I create the extension and apply it to the project, and then I define some tasks, but I have to defer the evaluation of that configuration because the extension I've added hasn't been populated with data yet, right? So we have this whole configuration ordering thing, right? It's this whole, I have bits of the model that get poked with data, and then somehow I have to guess or make some good judgment call on when I can reasonably assume that that information will be available, and then make a determination on what its value is at that point, right? And basically, it's an enormous pain because of all these hacky workarounds, and it's unreliable, right? Because there's really no guarantee that I'm going and finally capturing the state of that model element at the right time, because someone can always mutate it later, possibly. Right? So what are the existing workarounds that we have for this, right? So the first one is you put everything in after evaluate, right? So you go and you do some configuration or you create your extension, and then everything else goes in this big giant after evaluate block, and then hopefully you're evaluating that after all the stuff that should have happened to whatever those models that you're reading, right? But the problem is that's not really correct either, because anyone else, either in a build script or another plugin, can also do configuration after evaluate, and perhaps you depend on that configuration, but there's no really guaranteed ordering on when that happens, because anyone can register an after evaluate block after you and basically break some stuff that you did, right? So it's not really a solution either, right? The other option is to use convention mappings, which is a little bit better. You're basically deferring all the way to execution effectively. But like Luke said, we kind of wave our finger at people, like, don't use convention mapping, it's an internal API, and then in the same breath we say, well, but there isn't really a solution to not using it, so yeah, it's okay, we understand. But in the end, it's also really not the best solution, right? And then there's other weird hacky stuff like, well, just put the configuration in a closure, and then hopefully either the method that I'm calling accepts the closure, and then we'll just evaluate at execution time. But if the API doesn't support that, then I'm kind of hosed. Or I can do something like a lazy G string, right? I just pass it a string that's really evaluated lazily as a closure. Again, they're all just really terrible solutions to solving what should really be a simple problem, which is I should know that this value I'm reading in is done, is finalized, right? Or realized is the sort of nomenclature that we use, right? So that's the configuration ordering part, right? The other bit is that basically plugins are total black box, right? When we apply a plugin, by we I mean the Gradle code base, the Gradle engine, right? Applies a plugin, that plugin could do anything, right? So we can't really infer any information about plugins. Plugins aren't transparent, right? Which means all the smart parallelizing and the ordering and the caching and mechanisms and stuff like that we talked about earlier. We can't do that because we can't infer any information about the plugins that people write because they're just some big giant arbitrary block of imperative code. Right. So really the idea is that we structure plugins and we structure configuration into these sort of really discrete little elements that describe what they do. And they describe what they do in the sense that they describe what they poke, they describe what they mutate, their subject, and they describe what they need, right, their inputs, right? And then it's really easy to decompose that information into a meta model, right, that we can infer things from. Right? So that's what we're trying. We're trying to allow Gradle to understand what your plugin is doing, and by doing that, it can do all these sort of nice optimizations and stuff, and make sure that these inputs to your plugin rules have been populated with all the data that they need, and that they're immutable, right? And then the final performance, thing is that for a given task, which is kind of the final executable element, right? For some given task, I'm only ever going to do the configuration. I'm only going to create the objects. I'm only going to evaluate the code necessary to construct the model that's an input to that task, right? All right, so there's some new kind of concepts that we're introducing as part of this, right? The main two are what we call the managed model. And basically the managed model is the big graph of objects that Gradle manages internally, right? And this includes the model elements themselves, them and their data, their relationships between each other, right? This model element is a dependency of this other model element. It's an input to it. And also the rules, the code that manipulates those bits of data, right? That's all the new model, right? And the rules, the configuration rule, is really just some discrete unit of code that either adds to, updates, or reads from the model, right? It's just some function that interacts with the model in some way. Okay? All right. Now, there's really two main bits to a rule, right? A rule, again, is just some bit of code. But rules have, for the most part, subjects, or they really have one subject, and then 0 or more inputs, right? So a rule has, what is the thing that I am manipulating, right? What is the object in the model that I'm acting on? And it really means, it's typically, this is the thing I'm modifying, right? This is the model element I'm updating, or the collection of tasks. I'm going to create a new task, so the task collection is the thing that I'm mucking with, right? And then inputs are other bits of configuration that I need in order to make the decision on how to modify the subject, right? And another rule input can be any other piece of the model. And what we can do when we model these things in this way is we can do stuff like, first, we can enforce immutability. So we can make sure that a rule can only ever modify its subject, right? So it can't do any work that we don't expect. And then we can guarantee that the inputs we give to the rule have been fully realized. Really, this is all the information. Nothing about this thing is going to change because all the rules that act on this input have already been executed. Yes, question?
Is it helpful, I'm pretty familiar with string, is it pretty helpful to think about it as, when I'm given a beam by injection, I know that it's ready to go?
Yes, so the question was, if I'm familiar with Spring or Juice or some other dependency injection type of framework, is it basically the same idea? Yes, right? So your rules, we inject the model elements into the rules, right? We hand them, we're saying, here's the thing, it's all done and ready to go. Here you go. All right, so configuration rules generally either create new model elements or act on existing elements of the model. And basically, we refer to these different types of rules broadly in two categories as creation and mutation rules. So there's really two broad categories of rules. Rules that create new things and add them to the model, like declare new model elements, right? You can think of the analog to a model element would be like an extension or an extra property, right? Some new thing I'm adding to the build language. And a mutation rule is just some code that's going to manipulate that or create tasks based on it or something like that, right? Okay, so a creation rule, right? So a creation rule adds a new top-level element to the model, right? And again, when I say top-level model element, the legacy analog to this would be like a project extension, right? Some new type of thing that's now accessible from the project object. Right? Basically, you define these rules by defining a method and annotating it with the model annotation, and we'll see what a code example of this looks like in just a second. And then there's basically some contract rules on what these methods should do, and effectively a model element just returns the thing that we should add to the model, right? Very simple. Also, creation rules can take as arguments inputs other model elements, right? So I need as an input to create this thing, some other part of the model, and that's fine. So this is basically what that looks like. So basically the top, we're just creating a Groovy bean, right? We're just creating a regular Java Groovy Pojo, right? So it's called person. It's got two properties, first name, last name, okay? So in this case, we're defining a model rule, and this is a creation rule. This is something that's creating a new type of thing. And the type of thing it's creating is a person. So in my method signature, right, it just returns something of type person. And then in the implementation of my method, I create the new object I want to put in the model. And in this case, we go ahead and populate it with some data as well, and then spit it out. Right? By default, we interpret the method name to be the name of the model element, right? So in this case, I'm saying the method name of this rule here is called person, right? So Gradle says, okay, the name of this new person thing in the model is going to be called person. So there's going to be a new model element with the name person, and it's going to be this object. You can overwrite that if you want, right? So I can define any arbitrary name for this method, and then I just pass as an argument to the model annotation, hey, I actually really want to call it this. Okay? So those are creation rules. Those are, again, I'm creating new things and I'm putting them in the model. Now there's this new type of object that people can manipulate either via other rules or even via the model DSL, which we'll talk about later. So the other main type of rule is what's called a mutation rule. And a mutation rule, kind of self-explanatory, right? It's a rule that modifies some piece of the model. And there's different annotations that we use for mutation rules, and they really signify like when that rule is going to be executed. So the ones are mutate, and then defaults and finalize really just say ordering, and we'll talk about those in a minute. So the conventions for a mutation rule is the rule will return void, right? The rule doesn't return an object, it just acts upon something that we get, right? It's the dependency injection thing. I'm going to hand you the thing that you're going to mutate, right, as an argument. You define at least one argument to that method, and that argument is going to be the subject, the mutable model element that we're dealing with. Okay? And then creation or mutation rules can optionally define any number of additional arguments, and those arguments will be the input to that rule, right? So I'm basically defining that my rule modifies this thing, and I need the information from these things in order to perform that logic. So some information regarding binding. So this is, again, goes back to, if you want to think about all this stuff like Spring dependency injection stuff, same type of deal. So, okay, how does Gradle figure out when I define my arguments where to get that object and which object it should use, what model element it should use to pass? So you can really do two types of reference binding. You can either bind by type or by path. So by type is really the default way that, for the most part, we do this. And really what we look for is we search in the root of the model for just something that matches that type. So if I'm saying that one of my inputs or my subject is a person, I'm going to go through the model and I'm going to try and find a person object. And then when I find it, I'm going to go ahead and grab it and hand it to the rule, right? If for any reason that's ambiguous or something, or if I want some nested object deep in the hierarchy of my model, I can bind things by path. And I can say, no, I want organizations, Gradle, people, Mark. That's the guy I want, right? That's the person I want, is this particular one. And then you can reference it by the model path, right? Very similar to we do any other kind of groovy object reference stuff. Yes, question?
Is there an easy way to actually do that, like display what it is?
Yeah, so the question is, how do I get what the path for a particular model element is? And the answer really is to use the model report, which we're going to show it at the very end, but basically there's a new type of task that we provide that prints out a report of everything that's in the model. Right? So this is kind of the example I just showed, right? Binding by type. So the simplest mutation rule is a rule that accepts a single subject argument, which is the rule subject, and it's bound by the subject type. So assuming I have one person thing currently in the model, and I want to modify it some way, I would define a rule that looks like this. And basically, Gradle, when it executes this rule, decides to evaluate this rule, it's going to hand me that person object, right? And then I mutate it in some way. Right. Okay, so optionally, I can bind any of my inputs or inputs and subject by path, right? So in this case, we have a number of rules here, right? We have 2 creation rules. So one is creating a person called first. And again, the model element is called first because that's the name of the creation rule method, right, by default. So I'm adding to the model a person and its name is first. And I'm adding a person and the name of that model element is second. And now if I try to do bind by type, right, we don't know which person you're talking about, right? So in this case, sorry, what was the question?
What would happen in this case? Would that be an error saying this is ambiguous?
Yes. Yes. So here we say, okay, I'm going to annotate using the path annotation and then pass a string the path of the particular model element I want. And now Gradle knows, okay, so they want the second person, right? So the question was, if I don't do that, what happens? Right? So the next slide. So if I don't do that, Gradle will tell me, okay, we can't bind that subject because we don't know what thing you're talking about, right? So you'll see here, there's a problem with this particular model rule, and this is telling me, okay, here's the name of the rule. The name of the rule is that method, right? And saying, hey, you're just asking for something called person, but there's actually 2 people, first and second, right? And we even say these are the rules that create those 2 items. Right? And this kind of really descriptive behavior, and we'll go into more information when we talk about the rule source plugins, but this alludes to what Luke was talking about now Gradle understands not only the model and what's there, but where it came from, right? Which before we didn't really have any of that information, right? Before, if I have some, even normal Gradle users saying, well, there's some task called jar. Well, where's this task coming from? Well, it's actually being applied by the Java plugin. Oh, okay, that makes sense. I can look at the docs. Why don't I have a task called clean? Where's the task from clean coming from? Well, you applied the Java plugin, and the Java plugin applies the base plugin, and the base plugin defines a lifecycle task called clean. Well, how would I know that? You wouldn't. You just have to know, right? That's a total internal implementation detail, and the only way ever a new user would ever know that some bit of their object model is coming from somewhere is by digging in the code or the implementation, or digging into the code for a particular plugin they're using and finding out what it's doing, right? So in this case, Gradle knows that I applied some rule source plugin called rules, and that plugin has a method called update second person that's looking for this thing, right? And also that these model elements are created by this rule source plugin and this particular rule of that plugin, right? So now we have traceability from our model back to the code that created or manipulated those model elements, right? Which is really going to ease the burden of, okay, I applied a plugin and I applied with the other plugin and somehow they clash in some way and my build script exploded, right? So how do I trace that back? How do I know if I have a complex build, I'm using half a different plugin, which one is stomping on the other, right? All right, so, yes.
In the old model for plugins, you have an extension. So if I create a person extension, and then I could create an extension container to contain both of them.
Mm-hmm.
What's the analog in the new one, since both first and second are the same type?
Yeah.
Is there an automatic container?
Correct. So,
or do I need to ask for it?
yeah, so the question was, in the legacy land, I can create containers, really like domain object containers, right, that contain instances of a particular type of model object. Is there an analog to that in the rules? And yes, so they're model maps and model sets. So there's certain type of collection types that are rules aware, I guess is a way of saying it. And and they work with managed model elements. And we'll talk about that a little later and show examples, and there's a lab on that kind of stuff too, right? So I wouldn't have multiple people just shoved into the root of my model space, right? I would probably have a container, right? Like organization, and it would have a members, and that would be a collection of these types of things, right? So yes, there is a way to do that. So the type binding also works with generic types. So in this case, generic type is just something I made up. I'm saying I have a generic type of a string model element and a generic type of a Boolean, and I can say I want the string one, right? So I want specifically to take generic type arguments into account when we bind inputs and subjects to a rule. Right? So it works exactly the same way. And this becomes really important when we talk about those container types, right? Because like I want the container of tasks versus the container of people. Those are two different things, right? And we express that via generic type arguments, right? And again, if I don't tell it which one I want, we'll get an error, right? And this is actually more specific. It's not even that there happen to be two. Is if you happen to just express as a subject or an input, and you try to bind by type anything that's a generic type, you have to give us the type argument, right? So we don't allow any sort of ambiguity there. So you can't omit the generic type arguments in this case. All right, so what can I bind to? What can I define as an input or as a subject to a rule, right? Anything in the model. Okay, well, what's that? All right, so which really means anything that's in the new managed model space, which includes any model elements that are added by other rule plugins, elements that are added by the model DSL, so you can create new model elements even in DSL declaratively in your build script. Implicit elements such as tasks, like the task container is sort of an implicit object that we pre-populate the model with that you can access. And then lastly, basically, if I want to know, it's like, well, what all is in the model? What all can I get a handle to? Basically, anything that shows up in the model report. And we'll show that off a little later, but basically I can say, hey, Gradle, what all's in the model? And we'll print out this big report. It's a work in progress, so it's a little overly verbose right now, but probably more information than not enough is pretty good. But at least gives us some idea of both what am I doing, and it's also kind of a nice validation tool that your plugin is working properly, because you can apply your plugin and run the model report and see what the final state of what your plugin did, right? Without doing like, well, print line model.person.name at the end. Oh yeah, it came out right, cool. All right. So we talked about before, rules can have subjects, right? The things that they modify, and inputs. So inputs are optional. You don't have to have an input to a rule, but you can have any number of inputs. So basically arguments 1 through n of your method are going to be the model inputs, right? And we say these should be treated as effectively immutable. When we talk about managed model elements, we actually enforce immutability. But for these, basically, these are non-managed, right? You provided an implementation for that object. Technically here, I could modify that person. So this is why we talk about the managed model, and the eventual goal is to say, define all your model elements as being managed, and then Gradle will take care of the immutability problem for us. So we'll talk about that a little bit later. But what this means is that this basically creates a dependencies between this element of the model and this element of the model, right? Which means that if I want to know something about the collection of tasks, it means I have to realize or configure this person, right? And in this case, in most cases, we want to know about the task, but it also means that if I don't care about this subject, right, my current build execution, I'm running some task that's completely independent to this thing, then I don't have to evaluate this rule. I don't have to run the configuration necessary to create some piece of data that I don't care about as part of my current execution context, right? And also, like Luke, mentioned, basically this inner closure is also additionally a rule, right? So in this case, if I'm not running the print name task, then I don't even do any of this evaluation. Yes, question.
If your input there is a single instance of person to be injected, is it meaningless to say list of person? What would that
No. So if I was to say a list of person, I'm going to look for a top-level model element that happened to be a collection of persons. Right? So there are some, that kind of brings about, the question was, if I have a list of persons, does that mean anything different? And yeah, it does. In this case, we're going to explicitly say, is there a model element that is of a type collection of persons? One of the limitations is, well, if I don't, I have a model element of type person and a model element of type person. Can I say I want all the people and like coerce all those into a collection? That's currently not possible. But that's one of the limitations of what we're at right now. Good.
Are these inputs coming in, like tasks, for instance, it looks like it's now kind of being provided for you rather than like ripping it off like the project container or something? Is that like a new
Yeah.
technology now?
So the question was, what is this model map task thing, and where is that coming from, and why isn't it project.task container or whatever? So yes, basically this goes back to the legacy bridging stuff, and basically what we're doing is we're bridging the task container, the project.task container, into model space via this mechanism, right? So we're exposing the project's tasks as one of the new collections, which we'll talk about a little bit later, which is basically a map of tasks, right? So that's how we expose that sort of legacy construct, which is a task, to the new rules. Okay? So you can pretty much look at this and kind of figure it out, right? I'm saying I need this person, and based on the information from this person, I'm going to create this task, right? So I'm saying this task, this piece of configuration depends on this person.
Can person be an interface?
So the question is, can person be an interface? Yes. Yeah. So basically, there's the idea of we have a view, right? So the input is really a view to an object, and if it matches that contract, right? If it isn't it.
For public APIs
Yeah.
and for immutability.
Yep. And when we talk about managed models, it will always be an interface. It really will. It will never be a concrete implementation because Gradle will provide that concrete implementation. There's another question?
For this particular rule, does it say anything about the cardinality of person objects you can have in your project?
All right. So the
What happens?
So the question was, is there any implication about the cardinality of person objects? Yes, basically we're assuming that the root of the model has exactly one person. Right? If there is more than one, you would get an ambiguity error saying, I don't know which person you're talking about. And you would either have to solve that by saying, explicitly stating with the path to the particular person that you care about.
But this specification can only be done by the plugin author. It cannot be done. Like if I, as a user, take a plugin from some third party and this plugin expects some model element to be only there once, and I have it twice in my project, I cannot resolve this for the third party plugin, can I?
So the question was, if I'm using a plugin that expects me to define one person, and instead I define more than one person, how do I take care of that, right? So really what would probably happen to you, basically treat this the same as extensions, right? So plugins probably aren't going to create root model elements in the sense that there are going to be a bunch of different ones that you configure. They can configure a root model element which is global to that configuration, right? So if I'm creating a markdown plugin, I'm going to add a markdown model element, and then that's going to contain all the bits and pieces that you need to set. And if I expect one source directory thing, that markdown model element is going to have one source directory property that I'll set, right? So we're going to enforce this via like static typing, effectively, right? Does that make sense? There technically that model element type will be like something on the class path that you could conceivably create new things and shove in the model. And that's another thing too. Is how do we make things like private or scope them so that people don't break stuff?
So the problem could only arise if we are using some kind of shared API data structure that's known to both me and the plugin author.
Correct. So that the idea would be that you solve that with the same way you do extensions by effectively namespacing them under a common root model element, right? Under a common path. Right? Go ahead.
So this method signature says we have a dependency on the person element, and then inside we're really just using two pieces of that person element, two fields, the first name and the last name.
Correct.
But the dependency is on that top level model element,
Yep.
the person thing. And if I wanted to be more granular, I have to expand my signature and maybe revise my model to be more
Yeah.
granular.
So the question was, if this person, in this case, person is like a complex object, right, which has multiple properties, but I'm depending on the whole thing. Really, the goal is to depend on things at the granular level, right? Is if I have some big giant like extension object, maybe I don't need all that information to make this decision. I want just one little piece of that, and we can do that. I could do something like, hey, I only depend on the first name of this person, right? By using like path or something like that. So
Okay, I was going to say, do you have to break the
Yeah.
person element apart more, or can you just declare it right there somehow?
you would have to declare, currently the only way to do that would be to use the path to say, I declare on person.firstname. Right now there is no way to do that by type. Like, how do I evaluate a piece of a managed model element? Currently that's not possible.
Is there anything being told implicitly by the ordering of these arguments? Is that
No, yeah. So the question was, does the ordering matter? The ordering only matters that the very first argument is the subject, and then the other arguments are inputs. So there's no implied dependency. If I had multiple inputs here, there's no implied dependencies between them. Only if there was another rule that established a dependency between them. Okay. Yep. You got a question?
When you declare the creation of person, like the reference binding in the previous slide,
Yep.
you then decorate that person object with Gradle internal objects,
No. So
or you purely have person object?
yeah. So the question was, let's go back to the very first one. So the question was, do we decorate this person object with any of the Gradle internals, kind of like we do task extensions and stuff like that? In this case, no. And you know we're not because you're calling new, right? In this case, you're controlling this is what we call an unmanaged model element. You control the implementation and you control its instantiation, so it's effectively a dumb object that doesn't do anything that the class doesn't do. Right? When we talk about managed model elements where Gradle controls the implementation, then yeah, there's a little bit more stuff that comes along with those. Yep.
So can we have some DSL syntax sugar for those unmanaged DSL model elements?
So the question is there any DSL syntactic sugar for those? And basically, no. Yeah. So basically, in this case, person simple. So in the DSL, I would say person, and then I would have a closure, and I would say first name equals, last name equals. But if first name was a complex object, then I wouldn't be able to configure it via closure unless I did some goofy stuff, provided a method that took a closure, all that stuff, right? Yeah. Nope. Yeah, we don't do anything dynamic. We don't create proxy classes or anything for those. They're just straight the implementation you hand to us. Okay. So this slide is just kind of showing, demonstrating that a subject depends on its inputs, and we basically create a graph of these, right? So in that case, the task container contained on person, and if person was a subject to a rule that also had inputs, so on down the line, right? So we evaluate all this configuration in the correct order. So given the fact that Gradle establishes a relationship between a rule subject and a rule input, right? We enforce the fact that those configurations need to be done at a certain time, right? This is the whole configuration ordering thing. It's like, well, how do I know that all the properties have been set on this thing before I use it to determine something else? Okay? So given that idea, and hopefully everyone can more or less read this. I had to make the text kind of small to make it fit in the slide. But what's the problem here, right? So here we're creating a model element called first. It's a person. Creating a model element called second, which is a person. And then we're defining a rule. And the subject of the first rule is the first person. And the input is the second person. And then the subject of the second rule is the second person and as input of the first person. Right? It's a circle. It's a cycle, right? Right. So this is, but this happens now in plugins. We just don't know, right? Like there's already plugins that are out there that even within a plugin, or it depends on other plugins, because we're doing like plugin composition, plugins applying other plugins. This already is the case that we just either it's not explicit because Gradle has no way of knowing, right? Or just incidentally it's the case, which is why you have to apply plugins in certain order, and you have to put configuration in your Gradle script in certain order, right? Which shouldn't be the case. If the idea is that our model should be completely declarative, and the manner in which I declare it should have no bearing on what the final result is, right? Whether I tell you that the name of this task should be, foo now or later shouldn't make my build script explode, right? But because of the way that we're doing configuration now, and because of the way this imperative nature, right? Again, we're sort of almost just procedurally evaluating this configuration top to bottom. That if configuration down here depends on configuration up here that hasn't happened yet, it just explodes. And with like no good information, right? It just goes, I looked for something and it wasn't there, and it's probably some internal thing that you don't even know what it's supposed to mean anyway, right? So you have like no traceability, right? So this is explicit, right? We're explicitly saying that to this model element depends on this model element, and this model element depends on this model element. And since that's explicit and defined in a structure, in the form of a rule, Gradle can infer things on it. So we can tell you, yeah, dude, you can't do that, right? We can say, you're saying that first depends on second and second depends on first, so no, right? And more importantly, again, we have that traceability. We're saying that first is defining a dependency on second via this rule. And there's another rule here that's saying the inverse is true, right? So now I know where to look, right, for this problem. I know, oh, I got to go look at the code for the rules plugin to see that it's doing something naughty, it's misconfigured. And probably more than likely in a real scenario, these would be rules like in two different rule source plugins, right? You say, oh, these are conflicting with each other. These are doing something bad, right? They have a circular dependency between each other, right? All right. So finally, rule source plugins. So I've been showing you these little code snippets of these methods, right? And like, well, where do I put these? What do I do with this stuff, right? So rules are typically applied to a project in the form of a plugin, right? Same kind of concept that we've been doing with legacy plugins. So we use the term legacy from now on, right? It's a show that it's just the way things have been done for years and years. Right? And rule source plugins are applied in exactly the same way. Use the exact same syntax to apply a rule source plugin. It's just the implementation of that class is different. And basically, to write a rule source plugin, or rules plugin, or whatever, we haven't really come up with the wording for these very well yet. So I'll say rule source plugin for the purpose of this workshop. Is a plugin extends the rule source class. And like Luke said before, there's nothing special about the rule source class. It's really almost like a marker class, right? We're just saying it adds with some type safety and stuff like that, but doesn't provide anything. It's just an empty interface. So your plugins would extend from rule source rather than implement plugin project or whatever, right? So there's some rules on how you define your rules in a rule source plugin, obviously. Right? Can't just do whatever you want. So a rule source is really just a stateless collection of methods, right? It's a completely stateless just group of code, right? That being the case, since it's stateless and it's just logic, we're never going to instantiate one of these things ever. It cannot declare a constructor. It must directly extend from rule source, which means you can't have a rule source plugin which extends from a different rule source plugin, right? In that case, you do the same thing you do now with plugin composition. I would just apply that other plugin. It doesn't make sense for me to extend from it, because then you could overload methods, and there's no, or override methods as well, and we don't allow you to do that. Right? So if I need to build upon the capabilities of another plugin, my plugin would apply that plugin, right? It can't define instance variables. Again, so we're never going to create this thing. It's not going to have any state. It can't have any instance variables. It can define static, like constants and stuff that you can use if you want. Question?
What would that look like,
Well, I'll show you that in just a second. Yeah. Methods cannot be overloaded, so I can't have two rules with the same name that just take different arguments. They have to have unique names. Right? And the method itself can't define generic type arguments because, again, that doesn't make any sense in the context of a rule. Okay. So this is what a rule source plugin is. It's just some class. In this case, we're calling it rules. It extends from rule source, and in this case, we define two rules. We define a rule that is a creation rule, right? We're creating a new model element called person of type person, and then we're defining a mutation rule called update person, which basically populates that model element with some values, right? And I'm going to apply plugin rules. Right? When I apply this plugin to my project, nothing happens except for the fact that Gradle parses these methods to figure out what they do, right? So if I never need that person object, none of this code is executed, right? This goes back to the we lazily do everything. So if no other part of my build script or no task needs this as an input, this person model element is never created. So there's zero overhead for applying this plugin, right? Apart from parsing, which is very, 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 very fast. Right? So that kind of goes back to, when you're really trying to crank out the speed in your builds, there's a lot of folks that just go, well, all projects apply a whole ton of plugins, and a whole ton of plugins only apply to like 2 of my projects, but I'm still applying those plugins to each of my projects, and Gradle is effectively still executing all that logic for a bunch of projects that they don't apply to. And as a build user, you don't really think about it, and you're like, that's trivial, but that's overhead, right? It's like if I have a bunch of projects, and one of them just bundles documentation, and I apply the Java plugin to all of them. So I'm creating source sets, and I'm creating tasks to compile those source sets and all that stuff for a project that's it's unapplicable for, right? But in this case, you don't really have to worry about it because it's all lazily evaluated. Okay. So to answer the question, well, how do I apply a plugin from another plugin? We also support the notion of, I'm calling them hybrid plugins. I'm going to go ahead and trademark that, right? And many of the plugins that are using rule support right now in Gradle core are implemented in this sense where it's a combination of legacy imperative code and rules. But basically, this allows us to get an instance of the project object. Right now, we don't expose the project as can't be an input to any rules. That's possibly going to happen in the future, but right now you don't. So if you need to do something to the project, like apply another plugin, you could do it like this. So I could just say, I'm going to find a regular plugin that implements plugin. And then inside of that plugin, I'm going to define some inner class that extends rule source. And basically what we're doing is when we apply a plugin, we go searching through that plugin saying, hey, does it have any inner classes that extend rule source? If so, treat those as rule sources. Right? So basically when I apply a plugin, I'm going to call the apply method, which will actually apply the Java plugin, and then I'm going to register this rule. Right? Question?
What's the namespace of the edit person? Is it directly on the project, like a convention object, or is it like an extension?
So the question is, when I say person, that's scoped to what? And it's scoped to the root of the model, right? So in the sense of the project, inside of a build script, using the DSL, you could access something called person inside of a model block. So inside of that model block, there's like, this is model specific sub. But there's not going to be this isn't like adding an extension to the project object, right? Because the project object isn't managed, right? We're adding something called person to the model, which is this whole kind of separate mechanism, which can be used from either rules plugins or inside of a build script, it can be used from something called model. But if you have I guess what we're eventually getting to is, well, if I have some other legacy plugin that needs to access this, no. So basically, model elements can only be accessed by rules. It can't be talked to from any other thing. Only rules can talk to model elements because that's the only way we can control all that configuration, right? So there's no bridging back to legacy land for that yet.
I was just going to say, you
Sorry.
can't apply my plugin to another plugin that's
Yeah, so the question was, I can't have some other like legacy plugin apply my plugin and then use this person model element. No. That plugin would have to access that model element from a rule. All right, good.
How do you restrict the scope of closed source in a multi-module project? Or does it, like, is rule always applied to rule?
Yeah, so the question is, how is this scoped in a multi-project project? So each project has its own model space. So I could have a person model element in every project. It's per project. Yeah.
Would it be possible to use, for example, shared objects between those?
So the question is there a way to share model objects between projects? Luke isn't here, is he? I don't believe there's a way to do that right now. No. So if I... well, the problem is that the project object itself isn't accessible from rules. So there's no way for this rule to say, go get the model element of this other project's model space, because there's no notion of projects in the rule space. So currently no. So the model is scoped to a project, and all the access is sort of intra project right now.
You may be getting to this later. So if I have a body of plugins that I or my company have created, you should start out on the leaves, the ones that have nobody applying them, and convert them, and then move inward. Is that correct?
Yeah. So his question was, if I have a collection of plugins that sort of build on each other, I should probably redevelop the sort of the ones at the end of the stack, right? Because if I redevelop this guy and he depends on his stuff, that's not going to work because I'm going to be recreating this stuff as model elements, right? And I can't access those from non-rule plugins. That's correct. Yep. Start from the outside, work in. Chris?
So the rule source classes are basically a replacement for what used to be a plugin generic project. What about other types of plugins?
So the question is, can I apply a rule source plugin to something that isn't a project? The question is, the answer basically is no, and because really it's not the same mechanism, right? Really, you can think of a legacy plugin as this is just some block of configuration that's being applied to some arbitrary object, right? Rules are collections of logic that are bound to elements of the model space. So you can really only apply them to the model, right? The thing you're bound to, the thing you're being applied to is the model, and that's sort of per project.
So for settings and init scripts, the previous plugin model will still persist.
Correct. Yeah. So the question is, can I create settings plugins or init script, something that applies to type Gradle with rule source? No, not right now. Go ahead.
What if we have two models, for example, dependent on Java, two plugins dependent on the Java plugin, then the ordering would still be defined by the order in whichever plugin is to the project.
Yeah. So the question is, if I have two plugins, are you saying two plugins that apply this plugin or two plugins that apply the Java plugin? Okay, so yeah, so if I have two plugins that apply the Java plugin, yeah, because this gets called immediately, this is eagerly evaluated, yeah, the very first one to be applied would be the one that applies the Java plugin.
Yeah, but I want to define the ordering of those two plugins in which they apply the rules to what the Java plugin defines.
That's not possible, because this is still just the way old plugins work, right? If I...
Yeah, okay, assuming the Java plugin would be a rule-based plugin, rule source plugin.
Oh, okay, so this is a legacy plugin, this is a rules-based plugin.
Yeah. No, both are, we have two rule source plugins.
Oh, okay.
That depend on one rule source plugin. How do you order the variation order of these two?
So now the question is, okay, I have a rule source plugin, I'm applying another rule source plugin, when are those evaluated? And basically the answer is it doesn't matter, right? By the nature of rules, it doesn't matter when they're created. Gradle's going to go and create all the rules, apply all of them, basically construct them all, and then evaluate them in whatever order is necessary to create the dependency graph, right? So I'm not going to execute any of the rules until I actually execute a build, and then I'm going to go and say, okay, I'm going to apply all the plugins, but really that's not going to do anything. And then I'm going to evaluate the rules in the correct order. So it actually doesn't actually matter what order the plugins get applied in, because they've been applied by the time I evaluate the rules. If that makes sense. Yes?
I'm going to ask a question I don't even want to ask because it's going to hurt my head. Configuration on demand.
Yes.
What happens to that in this world?
So the question is, configuration on demand. You don't even really need configuration on demand anymore. Yeah. Yes. I'm going to use Stepan's. It means this. Configuration on demand is this at the project level, at the really crappy granular scope. We just go, oh, you're building a jar for this project. That way I won't run the configuration for this project. No, what now we're saying is you're running this task. I'm only going to do the configuration necessary for that task and those tasks, right? So much granular scope. So it's way better than configuration on demand.
So
Yep.
that's for like in the future, right? Because that's not the case right now.
Yeah, that's assuming everything's rule-based, right? And, right.
Is there a reason why rule source is a class instead of an interface?
Is there a reason the rule source is a class instead of an interface? I don't know. I have to ask Luke why that. I think it's just an arbitrary decision. I think it was basically, I don't know, I guess if you implement an interface that doesn't have anything in it, that's just fine, right? So. Yeah, there you go. So we don't run into the subclassing problem. I guess that would make sense. Yeah, because the problem with interfaces, you can do multiple inheritance with interfaces effectively, right? But we don't want that. We want rule source plugins to have to directly extend from a particular base class, so they don't have any other weird behavior. So it's a class. All right. Question?
Yeah, so when will the built-in Java plugins and all those plugins, implement the new rule mechanism?
Eventually. All right. Yeah, so like Luke mentioned, there's already, we already have the sort of, prototype plugin. The Java plugin is built on top of the software model. The software model is based on top of rules. It's actually still some legacy stuff in there, right? So part of it is, getting to that. So the C stuff was built from scratch, right? So we just went ahead and reused the rules, but yeah, at some point.
So are we now saying that expanding the DSL is not the way to go in the future?
This is expanding the DSL. So the question was, were we saying that is expanding the DSL not the way to go in the future? No, expanding the DSL is the way to go in the future, but right now expanding the DSL is really hard and crappy, right? Right now expanding the DSL is hard because creating a proper DSL with extension objects isn't nearly as easy as it should be. But when we're creating model elements, especially managed model elements, it's much simpler. And we'll see a little bit later how we can do that and make it much easier. So yes, the goal is still to extend the DSL. This is just another mechanism. It's just a much better mechanism for doing that. Right? So when I say I'm creating a new model type of person, that's exactly what I'm doing. I'm extending the DSL to include some new thing called person, which has its own properties. Right? Okay. So did the thumb drives kind of make it around the room, more or less? Did anybody not get it? Okay. Did anybody not have the materials? You didn't get it? Okay. There you go. Do you not need it, Renee? Or yeah, can you? If you need the materials, yell at Renee. He's gonna move around. So like I said, the workshop and the labs are based on the latest and greatest. So basically, I've included a zip file of Gradle 2.6 in the materials. If you don't want to reconfigure your path and whatever, you could just expand it somewhere and CD into the directory or something like that to run it. Here we go. All right. Yep. There should be 4 in total floating around. Don't run off of my thumb drives. Yep. So yeah, so there should be 5 labs. Basically just a directory with a build.gradle file in it. Build.gradle file has some sort of setup code in there, and then a bunch of exercises. So.
So this is essentially converting this current task.
Yeah, so effectively what we're doing is, this is the simplest example. The example of I have what would be like an extension, and then I am creating a task of like a custom type, and that task uses as input to it the value from an extension, right? So legacy plugin land, I would have applied a plugin, the plugin would create an extension of this type, and then in an after evaluate block or some other weird way of deferring execution, I would configure a new task, and it would read the properties of that extension, right? But you have to make sure you order that in the right way. Basically, what we're going to be doing here. Oh, really? You're going to go to. Oop. Right? Is basically this example. All right, what I'm saying, I'm going to take something as an input, and I'm going to create a task. Right? In the example of the exercise, we're creating a task of a particular type.
So on mine, I'm converting a bunch of plugins that we created. I know it starts with the lead, work out that's great. But what is the most likely problem I'm going to have with my plugins that I've written?
The most likely problem you're going to have in your plugins is that they access something that's not exposed by the model. Right? That's more than likely.
And then that's a redesign.
Well, that's basically the moving forward there would be to identify, okay, what is your use case, and how can we implement something in rules land to satisfy that use case, right? So part of this exercise is, yeah, by all means, we want to have people start hammering this, right? Because we want to identify the use cases that the new configuration model doesn't satisfy, right? Or at least how can we, in the interim, bridge legacy land and rules land in such a way as to be able to facilitate that kind of stuff.
Community to tell you what
Yes.
problematic things they have done.
Yes, absolutely.
The rules change differently.
Yep, absolutely. Yep.
So what are the existing managed models, the built-in managed models? You mentioned tasks.
There basically aren't any built-in. Well, okay, so it depends what you mean by managed models. So what are the built-in things that we put in model space, right? There's some internal stuff, but really, as far as public API, just tasks, really. technically you can get it like the extensions container and a couple other things, but, huh? Component is really an element that's added by the components, by the component model plugin, right? So it's not really an implicit. If I don't apply any other plugins, really the only thing that's going to be in my model is my tasks. But there are some internal bridging stuff where theoretically I can do the project extension container as an input, but it's not really something we consider to be public.